Today we're going to talk about graphing a quadratic function, and we've talked about, not a whole lot, but a quadratic function is something that has an exponent like x squared, could actually even have, but we're going to be dealing with x squareds. But a linear equation, remember, is where it just has the x and the y, so now we'll be dealing with these, and we've been solving them by factoring, but there are other ways to solve them, so that's what we're going to talk a little bit about. So this is what's called standard form of a quadratic then, ax squared plus bx plus c. A cannot be 0, because if it's 0, then it would just be a linear equation with a bx plus c. And the graph of this is going to be a parabola. And if A is positive, the parabola opens upward, okay? And the vertex point, which is where it turns, like here, would be a minimum point. And if A is negative, it opens downward, and the vertex point will be the maximum point. So that'll make more sense once we start getting into looking at parabolas and so on. But those are some important things to learn and remember, and it'll make things easier for you if you remember those things. So we want to graph this. So we're going to make an XY table, but it's kind of important to find the vertex point, and we'll learn a shortcut way for doing that maybe later. And so it is kind of just trial and error, choosing some numbers. You've got to be careful because got to do your math right to make sure you get it right. So if we put a 0 in, well, both of these two are going to be 0 here to start with, so it just give me -5. So what am I going to put if I put a 1 in there? Well, this would give me 1 squared would be 2, or would be 1 times 2 is 2, minus 4 times 1 would be 4. So that's going to give you -2 minus 5 would give you -7. And now again, you might want to graph these as you go, 0, -5, because it's going to be important to kind of understand. We're looking for where it turns, like for the up or down part, okay? 1, -7. If I put a 2 in, 2 squared is 4, so we've got to do squaring first, remember. 2 times 4 is 8. 8 minus 8 is 0, minus 5 would be -5. So now you can see that it is going to start back up again, so that's going to really help me with the graph. Okay, if I put a 3 in, 3 squared is 9, 18 minus 12 would be 6, 6 minus 5 would be 1. And since, so 3, 1, 1, 2, 3, a parabola has symmetry, I know that the same distance from this vertex point down here, I'm going to have 1 over here. So now I probably have enough points that I can graph. Remember, it is a curve, so kind of curve them and they go out like that. So that would be the graph. Notice A was positive, so it opened downward, and this is considered to be the vertex point. In this case, it's right here. Okay, and it is a minimum point. All right. Let's try another one. Now we should notice right away that this one is going to open downward because it's got the negative sign there. So when we make our XY table, we put in a 0, we're going to get -1. So 0, -1. If we put a 1 in, 1 squared is 1, but then we have the negative sign because it wasn't in parentheses, so this will give you -1 plus 4 minus 1. So -4 plus 1 is 3, 3 minus 1 is 2. So 1, 2. I decided to put a -1 in. I'm not really sure why I did that, but I did. So -1 squared would be 1. That still give us -1 here. 4 times -1 to make this -4. So -1 minus 4 would be -5. Minus 1 would give me -6. So -1, -6. 1, 2, 3, 4, 5, 6. So looks like possibly it could be turning there. Let's put a 2 in now. 2 squared is 4, with a negative would make it -4, plus 4 times 2 is 8, so that would give me +4, minus 1 would give me a 3, so I get 2, 3, so it still seems to be going upward. If I put a 3 in, 3 squared is 9, so that's -9, plus 12, So negative 9 plus 12 would be 3, minus 1 would give me a 2. So 3, 1, 2, 3, 2. So now I can see it is starting to turn. So I know then that, again, to match up with this point, I'm going to have a point right over here. To match up with this point, I'm going to have a point right over here, and I can now draw pretty much a nice curve. Oops, I missed that point. And don't forget to put your arrows on it. So again, this would be the vertex point right here. That's where it turns on, and then it does open downward, so that is a maximum point there. And I did mention the word symmetry, I hope we understand that, but we have what's called the axis of symmetry. So when you have a parabola graph, down the middle of it is called the axis of symmetry. So if you fold over on that, well, this is the equation, x equals negative b over 2a. So this one asks us to find several things. Find the axis of symmetry, the vertex point, is it a max or min, and then graph. So you need to answer all those questions. So to find the axis of symmetry, the first thing it tells me to do, I'm going to put negative, and then what's my b term? Well, it would be, in this case, negative 6 over 2 times what's my a term, negative 3. So this gives me negative 6. Negative 6 divided by negative 6 is positive 1, but then I have this x equal, or I have the negative sign there, so x equal negative 1 would be my axis of symmetry. So that is my first point. Now, since I know that is where I'm going to fold over or whatever, that means the vertex point, the x-coordinate is negative 1. So to find the vertex point, I'm going to put in a negative 1 for x. So it would be negative 3 times negative 1 squared minus 6 times negative 1 plus 4. So negative 1 squared is 1. This gives me negative 3. Negative times negative gives me plus 7 plus 4. So negative 3 plus 7 would be 4. 4 plus 4 would be 8. So my vertex point will be an ordered pair. Oops, I add something wrong here. Oh, this is positive 6, sorry. And I get 7 as my vertex point. So negative 1, 7 is my vertex point. Okay, is it a max or min? Well, you can either graph it and then tell that, or you should notice, like we said, from right here, we know it's going to open downward, so the vertex point will be a maximum point. So you can abbreviate max like that. And now I'm going to think of graphing. Well, if I do know that negative 1, so I'm going to kind of, let me erase this and put it up here where we can look at something. This will help me choose my ordered pairs wisely so I don't kind of go off. So I'm just approximating here. If I go negative 1, 7, and that's going to be the maximum point, I know then it's going to turn downward, doesn't it? So if I put in a 0, put a 0 in here, I'm just going to get 4. So again, I have a graph on the next page, but it'd be nice if I can't, once I get rid of this, I can't go on. So 0, 4 is going to be here, and then you can use that idea of symmetry. You know you're going to have an ordered pair. This was 1 to the right of the vertex. You're going to have 1 to the left of it, the same distance, so it'll be right there. So I probably ought to put a 1 in also. If I put a 1 in, I'm going to get negative 3 minus 6 plus 4. So negative 3 minus 6 is negative 9 plus 4 would give me negative 5. So 1 negative 5 is going to be way down here. So now we can go to the next page and graph these things, which I think it's a graph. Hopefully it is, yes. So the vertex point was negative 1, 7. Then we said we got 0, 4. And again, using the idea of symmetry, I can know there's a point over here. And then 1, negative 5. Maybe. So I know again that there's a point over here. So now I can graph it. Be my arrows. And so that would be it.